Okay.
Pork grilled cheesy pizza, barbecued chicken pizza. Activities today.
No daily check, but I want you to find a scrap sheet of paper somewhere, a corner, a margin. Fill it out. No notes. Just fill it out. That. Yes. No notes. No calculator. Just find a margin. Fill them out. You got to know this stuff before we get started today.
Tomorrow, Friday, the 21st. Drama Club meeting, April 27th. School Missionary Room. We'll vote for a year-end award. All students welcome before Friday. Stop me this way at Woodstock 99. Here's the final celebration. Thursday, 27th. 6:30, November 7th, 5 all. Receive a complimentary ticket. All honors will be given out that evening. Monday, next week, Freshman Impact Day. All freshmen are required to attend. Freshmen for this day, comments and reports in different areas of the building. All students remember parking in the main lot is limited. Not quite half of that parking lot will not be available to the freshman impact activities go on. When accordingly, we're working on Monday. Don't please stand for the pledge.
Pay your tribute. Yeah, sure.
All have a great day.
Like the wind. Wait, where? It's gonna be in the. I'll find it. Yeah, you'll find it. Just start clicking the buttons and I'll like. That's what I do.
Lori, were you one of those kids whose parents put a leash on? Like the little harness with the leash?
My brother was. Yeah. I wasn't. I ain't talking to anyone. I'm quiet.
Okay, it's not a normal daily check. It's not graded or nothing. This is, you got to know this, so I want you to test yourself real quick. A margin, a napkin, I don't care, just somewhere. Can you fill this out without using notes? Start with your ratios on the triangles themselves. Then, from 30, 45, and 60, what are all of those trig ratios? Well, yeah, that's why there's 3 columns instead of 4. Because, yeah, because the sides are the same, isosceles. Opposite and adjacent are the same. Okay, we gotta know this because today is the day where we build the unit circle. It's not bad. It is literally this on repeat. You're right, I should. Oh, sorry about that. Okay.
Look at our notes.
It doesn't matter if you're wrong, just try.
So how do you memorize based on the neighborhoods? You just remember the two that has on it.
It's also the largest value.
I didn't memorize it.
Largest
there's
value.
6 numbers to memorize. It's a triangle already.
Oh. I drew the chart.
There's 6 numbers, and they're in order of largest angle, largest side, smallest angle, smallest side. Like this is less memorization than your phone number. Okay, you got to know 5 numbers, the concept of small angle, small side, SOHCAHTOA. There you go. You know those things. You can fill this out.
Yeah, but there's no numbers.
No, that's what you have to find. That's what you have to know.
But what if we don't know it? Like, how do we find it? Like, how do you do sign if there's no numbers there?
You have to put the numbers there. That's the thing I said you have to memorize before we even got to this chapter, is you got to know those 5 numbers.
Okay. Thank God, Sammy. Perfect timing. Bye, Sammy.
Okay. I ain't gonna go over there yet. Remember that if this is isosceles, you can call these both x. Do Pythagorean to find your hypotenuse. If you have to create the whole thing from scratch. This comes off of half of a equilateral triangle. So you can call this 2x and x, use Pythagorean to find the missing side. If you have to reconstruct the entire proof of it to find those numbers, go for it.
Wait, those 2 things are the same, so I feel like I crisscrossed.
Yes, yes.
Okay.
Continue. Continue. Okay, it looks like we're either there, finishing up the last thing, or completely lost because we still haven't remembered what those ratios are. Wakey, wakey, Frank. You should know these. At the very least, you have to have the triangles. Because if you know the triangles and then SOHCAHTOA, you can fill out the rest. I just wanted to see if I can still keep my 30 seconds with being exhaustipated. So, from the beginning, 1 1 square root of 2. You got to know that one. That one should be a little bit easier to remember because 45 and 45 means the two legs got to be the same. In a 45-degree triangle, now from this angle, opposite and hypotenuse, but rationalize it. Sine and cosine are going to be the same because the two sides are the same. Opposite and adjacent are equal values. So regardless of which one you use, same value. If I flip that, don't do 2 over root of 2 and then try to rationalize it, just do square root of 2 over 1. And opposite over adjacent, when they're the exact same, ones. If I look at this guy, it's 1, 2 square root of 3, where we might get a little caught as we're plugging those on there if we don't memorize it, is we might be tempted to put square root of 3 on the hypotenuse just because 1, 2, 3 was our normal order of increasing value. But square root of 3 is 1.729-ish. So largest side, largest angle. Then, green. 30 degrees. Sine of 30 from here is 1/2. Cosine is square root of 3 over 2. Tangent is 1 over root of 3. Rationalize it. Their reciprocals, 2. Reciprocal, rationalize, 2 root of 3 over 3. And now it's root of 3 over 1. But the fun part is you don't. Same thing goes for cosecant and secant, since they're just reciprocals. And the tangent and cotangent will flop because now the opposite and adjacent have flopped. Okay? You got to know this. Because if you know that, you can fill that out. Okay? Today is the day. We got through example 3 and not much else, right? Okay. So just to make sure, I know that y'all did your test on Tuesday. Yesterday was off because everyone had testing and it was funky, which worked out nicely because I had to stay at home. While we're here, right after example 3, let's just make sure that we're still good. Let's take care of, since Levi's gone, number 6 and 9. Right after example 3, that practice page, I just want to do those two right now to say, hey, I remember how to do this. Okay? Yeah, we did. That was example 1. Okay? So first, you're going to say, what quadrant is that in? Draw your line. Use X and Y to represent your adjacent and opposite, respectively. Use Pythagorean to find your radius. Then go find all your trig ratios. Oh, no, no, no. Simplified radical, madame. Man, I swear that your eyes rolled far enough back that you could have saw me behind you. Simplified radicals, always. We are going to be accurate in this house.
Is that like before, like something?
Like square root of 20 would be called 2 root of 5.
Oh, yeah.
Okay. You just did 9. We usually do 12 in a semester. Usually. Sometimes 11, sometimes 13. Depends on variations to the schedule.
You just multiply it by
2 root of 5?
So if that's on the bottom, then
You would only multiply by root of 5 because no radicals downstairs. 2's okay, I know his dad.
So then once 5 is by itself, without the radical then.
Then 5 times 2 because now they're outside of radical land. Yes, ma'am. It was weak anyway. I'd give it like a 1.5. There's a whole rating system. It's based on volume, length, base.
you don't give me very much room.
Probably not. This is just to get us back on track before we start the next thing. It's been a up and down couple of days, so just want to get us refreshed with this before we continue. Okay, first one, do you have your placement correct? And your missing value correct? Okay, we'll be in quadrant 4. You do still call the opposite or the y portion of that negative 4. Remember, negative only denotes that it's going downward. That's it. It's just, negatives just mean direction when we're dealing with coordinate plane. When I do Pythagorean, negative squared becomes positive anyway. Make sure you simplify your radical, call it 2 root of 5. Notice 2 root of 5 to a negative 4. The entire thing is reducible in order to find your trig ratios. So if you wanted, you could rewrite this as root of 5, 1, negative 2 to reduce your ratios. Like, that's not the accurate place. That would be here. But I'm going to end up dividing all of my stuff by 2, right? I'm going to end up reducing all of them. So sine from our angle. Opposite over hypotenuse becomes negative 4 over 2 root of 5, but I could also call it negative 2 over root of 5. Make sure you rationalize it negative 2 root of 5 over 5. which means a negative root of 5 over 2 for its reciprocal. A negative root of 5 over 5 for cosine, just a negative root of 5 for secant. And tangent is a handy-dandy negative 2 and negative 1/2. Oh wait, the cosines are positive. Sorry. Yeah, you got it before I did, yeah. Hmm? The dose leeches over there. Only need one more. I mean, the irony of 3. Mm-hmm. So, 7 pi over 6, what quadrant we in? No. 2. 7 pi over 6? 210 degrees. 0 pi. Here's half of it. Here's break each quadrant into thirds. If it's 7 pi over 6, that's 1, 2, 3, 4, 5, 6, 7. Third. What?
You corrected us and you're like, no, that's a second. That's another problem point. Go back on the video. Yeah, let's go back.
So like, let's get to 20 guys. But it's still.
It's 3 cap per day. Okay. So, what is that if this is 7 pi over 6? What is the referencing? No. Pi over 6. Okay. If I'm in radians, I better stay in radians. Okay. It's always the acute angle, positive acute angle formed with the x-axis. What if I ask for the reference angle on number 6? Didn't we make a triangle with the x-axis? Could you find that angle? How would I find that? I could use arc sine, I could use arc tangent, I could use arc cosine. You would have to use an arc function to find it. Since I was given a opposite and adjacent, this angle right here would be the arc tangent of negative 4 over 2. And it'd be some funky decimal. Okay? It wouldn't be a special reference angle because it's not one of the special 30, 45, or 60 degree angles. Okay? But you can still find reference angles. It's just the positive acute angle formed with the x-axis. I don't know what that angle is off the top of my head, but I can find this just by doing basic right triangle trig. Okay? All right. Hopefully, we're caught up. All right. Yeah, we did. We sketched it and we found the reference angle. It was pi over 6. No?
Wait, what is this?
Thinking. Oh, there we go. I said you got to know it. There's your special right triangles, your special values. You got to know them. Okay? Now, cosine of each expression. Example 4. If I say the cosine of 120, first of all, what quadrant is that in? Okay. So if this is 120, what would the reference angle be right here? 60. Yep. Do 180 minus 120 and you get 60. Do you know what the cosine of 60 is? This is why I said you got to know that chart. You're right. Cosine of 60 is 1/2. Because the sine of 30 is 1/2, the cosine of 60 has to be 1/2. This. The cosine of that angle is 60. Or sorry, the reference angle is 60. The cosine of 60 is 1/2. But I'm in quadrant 2 right now. Will this x value be positive or negative? I'll have a negative x value. Will this y value be positive or negative? Will this r value be positive or negative? Always positive. So when I do cosine, I'm about to say adjacent over hypotenuse. Shouldn't I get not just 1/2, a negative 1/2? Because I'll have a negative adjacent over a positive hypotenuse. Because they're the same. The idea behind example 4 is that if you know the reference angles, the sine, cosine, and tangent of any one of those special angles all the way around the circle is the trig ratio you already know. It's just whether it's positive or negative. I don't. Because I knew this was negative x, this was x squared of 3, and that this was 2x. Because of its ratio. Yes. Okay. Because all of those angles follow that pattern. That's why the cosine of 60 is in your calculator, because it's the same no matter what size of triangle it is. So let's do a quick little cheater mabob over here. In quadrant 1, don't I have a positive for my x's and y's? What do I got in quadrant 2? Quadrant 3? Quadrant 4? Cool. So now, the sine value in quadrant 1. Always positive, right? We know that r is positive. If you want, I can write that next to this. R is positive, R is positive, R is positive, R is positive. X, Y, R. Okay. Sine will always be positive. What about cosine? In quadrant 1. Adjacent over hypotenuse. Always positive. What about the tangent? Always positive, because all of my values are positive in quadrant 1. How does that change when I go to quadrant 2 now? X is negative, X is adjacent. Which things have adjacent in them? So that means the sine will stay positive, but the cosine and the tangent, because they both deal with that adjacent value, are going to be negative. What's going to happen when I go down to quadrant 3? Not everything. R is positive. How about this? Sine is opposite over hypotenuse, which will be negative over positive. Cosine is adjacent over hypotenuse, which is negative over positive. And tangent is opposite over adjacent, which is negative over negative. What about sine, cosine, and tangent in this quadrant? Okay. Of course, we're going to go back to that color. Adjacent, opposite, hypotenuse. Adjacent, opposite, hypotenuse. Adjacent, opposite, hypotenuse. Adjacent, opposite, hypotenuse. What? Because the hypotenuse is the radius, which is always positive.
Yeah, so is that just kind of
Yeah. So in quadrant 4, opposite over hypotenuse. Negative over positive. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent, negative. What this allows me to do is, if I know that 60 degrees has a sine, cosine, and tangent of square root of 3 over 2, 1/2, and square root of 3, then that means at 120, it's going to do all the same stuff. It's just cosine is now going to be negative. Tangent is going to be negative. It tells me that when I come down to quadrant 3, sine is now going to be a negative square root of 3 over 2. Cosine is going to be a negative 1/2. Tangent will be a positive root of 3. When I go to quadrant 4, I know that reference angle is 60, even though the entire angle was 300. But I know sine, cosine, and tangent values for cosine or 60 are 1/2 square root of 3 over 2 and square root of 3. I just know that in this quadrant, it's negative, positive, negative. Well, I could do this for 60s, I can do this for 30s, I can do this for 45s. That's why we do that chart, so we know those values. Also, all of these, don't I just swap these two to 1/2 and square root of 3 over 2 and then reciprocal this if it's 30? So everything flops, then I change the signs. Look right above this. This chart is right there on your paper. Okay. The way that most folks will remember this, we call it all students take calculus. That is not true. That is why in the past I've had some kids say all strippers take cash or whatever they decide to make it up. However you're going to remember it in quadrant 1. They're all positive. In quadrant 2, what sine is positive? In quadrant 3, tangent is positive. In quadrant 4, cosine is positive.
Maybe something all students take coffee.
No, I don't.
They could use that for card. All strippers take card.
Why would they take check?
What's
Card, cash.
what's your Venmo? Okay. This means if I know, come up with whatever acronym you want. Okay. No, not there. No, not there we go. Oh no, I was just putting boxes down the way. I need boxes because we're moving. All students take calculus, right there. Okay? Yeah. That's the whole thing. No. Okay? So. So now, having done that, now let's talk about B and C in a little bit different context. What quadrant is 7 pi over 6 in? Third one. I got it now. Okay? Is tangent negative or positive in quadrant 3? And if I know that 7 pi over 6 has a reference angle of pi over 6, since I know the tangent of pi over 6 is, pi over 6 is 30 degrees, what is the tangent of pi over 6 or 30 degrees? This is why I said we should know that chart. What is the tangent of 30 or pi over 6? Root of 3 over 3. All I need to know is that chart. And then all students take calculus, or whatever your acronym is. In this quadrant, I know that that's positive. Done.
So we're like, you find the acute age, and then you take that angle and you find it on the chart.
Because if you know those ratios, all of them around the circle are those ratios. It's just positive or negative. Okay, 15 pi over 4 is too much. Because what is a full revolution? 2 pi, which is 8 pi over 4. This is too big. Go find its coterminal angle, though. If this is 8 pi over 4, how much more do I got to go? So here's 1, 2, 3, 4, 5, 6, 7. $15 pi over 4 is coterminal with 7 pi over 4. So what is its reference angle? Pi over 4. So if the reference angle is pi over 4, okay? Minus 2 pi, which I'll call 8 pi over 4. So it's 7 pi over 4 or 315 degrees. Has a reference angle of pi over 4 or 45 degrees. I don't even need to know the cosecant part for pi over 4. Cosecant is a reciprocal of if I know that the sine of pi over 4 is square root of 2 over 2, then I know the cosecant is square root of 2. Because the cosecant of pi over 4 is square root of 2, I just need to know if, what was the one I heard last year? All Sturgis teachers crackheads or something? I had a kid who transferred. Oh, yeah, your new principal is going to be the principal from Sturgis.
I thought it was the sister.
One of them.
Did everyone know that?
So in this quadrant,
I'm convinced I've never seen him in my life. I seriously don't. Sorry. Pi over 4, yep.
cosecant is a reciprocal of what? Sine. Since sine is negative in that quadrant, so is cosecant, because it's just the same number flipped. Negative root of 2. Now, this is if I know the ratios and all students take calculus or whatever your acronym is. This is cosecant. Cosecant is reciprocal of sine, not cosine. And welcome back. The other way that I can do this, okay, that's bouncing along through the concepts I should just know. But if I just don't know them, do you know this is in quadrant 4? If you know that the reference angle is pi over 4, that means you can also put your 1, 1 root of 2 ratios on there. Pi over 4 is 45 degrees. 45 degrees is 1, 1 square root of 2. If I'm in quadrant 4, do any of those need to be negative? That one? This guy. So now, go find cosecant. Hypotenuse over opposite. But that's reinventing the wheel. Some of us find reinventing the wheel faster than knowing the values. Okay? You can either pinball through the knowledge or just do a quick sketch and throw your values on there. Your choice. Okay? It's your choice. Let's try it. It all boils down to the reference angles. The reference angles are going to be 30, 45, or 60. I mean, it might be 0 or 90 if it's quadrantal angles. So the first step is, where is this angle?
That was a joke.
Oh, okay.
Sorry. I was just counting through these degrees. I don't know what I said.
Oh, if any of you borrowed my calculators for ACT, or if you took off with one the other day, please bring them back. I was missing like 6 calculators this morning. Those are kind of expensive. Well, what quadrant are you in?
Isn't it like this?
Is 5 pi over 3 less than or more than a pi. Okay, so you're past 180. How far?
So it's there.
So 3 pi over 3 is here. 4 pi over 3. 5 pi over 3.
So
I
what
know.
is 5?
So I have a question.
Oh, we're doing all of these?
Yeah.
Tears.
Yeah, about there.
Where does the triangle
Because it's
So is that 60 then? Because this is 360.
Yes.
And you go like around?
Yes.
So then do you take the tan of 60?
Mm-hmm.
But I'm confused how you, like how do we, I'm just confused how we got the things. Like how do I take?
Because it's 60. If this is 60, then you know root of 3.
So you just
1,
use
and
this,
2.
so you don't have to like find anything.
If you just know a 30, 60, 90
Yeah.
triangle,
Okay,
square root
so
of 3 is
it'd
across from that.
Okay. So it'd be,
30 is here, 1 is here, 2 is here.
So it'd just be root 3 over 1. Well, wait, opposite over root
Now
3.
careful, if I'm in that quadrant,
Okay. But then okay.
and since the tangent of this is negative root of 3,
Mhm.
then the tangent of this is negative root of 3.
Okay, I get it.
That's why we're practicing. Yes.
Mr. Sullivan, is this like after you like win something, or is it like a?
It looks very, very good on scholarship applications.
There you go. Like, is it ranking? Yeah,
But I feel like that's not very good. You're just like, oh, I participated. You know?
Isn't your whole generation about bragging rights and like,
Yeah, exactly. That's why I was like, don't do it because I feel like I'm not.
then you just don't say anything.
At least then you put it on your score.
Well, even if you just say participated in regional math competition, you don't have to say what you got. You just say you went. You were good enough to go. Yes.
You can go to
Yeah.
I know. So they probably like that.
Because most of the people who hand out money for scholarships don't know that.
You could lag.
Rich people rely on.
We could say selected for.
There you go.
I was hand-picked.
What quadrant is 5 pi over 3 in?
I had to read that I was just into
What quadrant is 5 pi over 6 in? What quadrant is negative 135 in? 3? So first make sure that you're talking about the right angle. Then, after that, your choice. You can put the ratios on the triangles. You can just manually put them on the triangles because you got a sketch. Or you can know the trig values of those angles, of those reference angles. Because this is tangent of pi over 3, but I'm in quadrant 4, so it's negative. This is the sine of pi over 6. I'm in quadrant 2, so it's positive. This is 1 over the cosine of 45. But I'm in quadrant 4, so it's negative. Okay? That's how you'll see me write out my answer keys. I'll use sine, cosine, and tangent because secant is reciprocal of cosine. I write 1 over cosine. Okay? And then you just watch out whether it's positive or negative.
I love this trick.
Yeah.
You only put them on that has the degrees first. Is that
Because it said secant. Secant is reciprocal of cosine.
so any of them is supposed to secant?
Well, in that little chart right above this, we only wrote sine, cosine, and tangent, right? This way you don't have to memorize secant, cosecant, and cotangent.
So only the
Uh-huh. If you know the special right triangles. Answer. The knowledge will absolutely be a part of it because this is the foundation of trig. I don't know. Go talk to Spear. Each school is allowed to submit up to so many kids in the different brackets. Being in pre-calc right now, you would all be in the 4th year math section. Yeah. And then after pre-calc, when you're in trig and calc, then you could qualify for the master's section.
So I put on my advanced math regional.
Yeah, you would say selected for advanced mathematics competition. Okay, tangent of pi over 3 is root of 3, so negative that is just boop. The other option is I could put 1 root of 3, 2 on the triangle, stick my negative there because I'm in quadrant 4, and then just go find the tangent. I can know that the sine of pi over 6 is 1/2. I'm in this quadrant. Sine is positive in quadrant 2, so it's just positive 1/2. Or 1, 2, root of 3. This guy's negative because I'm in that quadrant. Go find the sine. I could. Oh, no. We'll go back to blue. If I know that the cosine of 45 is root of 2 over 2, its reciprocal is just root of 2. Stick a negative in front of it. Or put 1, 1, root of 2 on here. Because I'm in this quadrant, I know both of these are negative. Go find secant. Okay? You have the choice of sketch the triangle, put the values on there, go find it like normal, or I know stuff. And everyone's going to come at it from a different perspective. Okay? All right. Next one.
Did you hear her? She goes, you have to look at the angle of it.
That was
That's
a good
not
one.
fun.
Holly's gonna get water.
I think it's
Were you an IE or a Y? Okay, that's what I thought.
Wait, what is that?
Holly's dad.
There we go.
Wait, what is this?
Oh, they were just ranking different video games. That was a D tier dad joke.
Wait, what is S stand for?
An S tier dad joke is one that everyone, just whether they grimace or not, just has to laugh.
Is he or sorry? S is for superior.
Y'all, we already did ones like this, where they didn't say this part. This was one of the very first things we did. Reminder that I hear everything. You would draw your arbitrary triangle, right? I'd put theta here, and if tangent is 5/12, I would put what where? Opposite and adjacent, right? I'd put 5 and 12 on there. Do you know your triple, or do you got to go to Pythagorean? 3, 4, 5 is a triple. 5, 12, 13 is another triple. But that's wrong, because what changes now? Sine is less than 0. What kind of numbers are less than 0? So where is sine negative, but tangent is positive? Third quadrant, which means I need to draw my triangle down in third quadrant instead. Still 5, 12, 13, those are backwards. There we go. So we did this, draw your arbitrary triangle in section 1. That's a review of geometry. What changes now is I'm going to say, because sine has to be negative, the only place that I end up with a positive tangent value, but sine is negative, is in quadrant 3. If I draw the triangle in quadrant 3, what do I have to change? Okay, my x and y values are both negative. Notice that tangent is still positive 5/12. Negative over negative cancels. They said, now go find the other ratios. I'm going to do both because everyone thinks at it differently. If I know this is opposite and adjacent, which is y and x, I would just quickly do Pythagorean and find r is 13. And because tangent is positive, but sine is negative, I would just jam my negatives on there and then do my x, y, r shortcuts. Remember that sine, cosine, tangent, cosecant, secant, and cotangent. They already told us that this one was 5/12. Remember my x, y, r shortcuts is this is y over r, this is x over r, this is r over y, this is r over x, and this is x over y. You don't have to draw it if you remember to put the negatives in the correct spaces. Remember the old geometry axiom, when in doubt, draw it out. Okay? Half the time we're only drawing or sketching these triangles just so we can wrap our head around it. It's not necessary to the problem. Now from there, we should be good to go. Green. That, from this angle, sine opposite over hypotenuse, or y over r, negative 5/13. X over r, negative 12 over 13. There are different ways to do it. You can draw it out, or you can do the x, y, r shortcuts.
But you have to memorize X, Y.
If you're willing to draw it out every time, I don't care.
Like, for saying that stuff. Yeah, you have to tell me before.
For that test, I usually cover that, and that. We're finishing unit circle today.
Is it in 5 days?
Probably Monday.
No, that's not Monday. It's Tuesday.
The quiz over the unit circle stuff, you should know.
On
We
Monday.
don't have to stop this weekend.
It's my.
It's not going to take the whole class. It's going to take 20 minutes.
It's gonna take me the whole class.
No, it won't.
Let's do it Monday.
I will not let anyone go over a half hour for that.
Let's do it.
Okay.
But Monday we'll have a good review.
I think we should have.
Are you not doing freshman?
I think I'm going to do whatever I can to keep us on track.
Yeah,
Monday is freshman.
freshman impact is a good day.
I don't care. So,
I want to go to that.
the big deal behind this is which one's positive, which one's negative. Whether you're going to use XYR shortcuts or you're going to draw it out, I don't care. Just make sure that it's in the correct spot. I'm tired of getting derailed and then, oops, we need to write stuff down. Y'all, remember that if something like secant is positive, secant is a reciprocal of what? So that means cosine was positive. Because they're the same ratio, just reciprocal. Oh, I've had a box up there for a while, but the XYR shortcuts are right there too. No, I'll have another box by then. Well, I got to tear them all down by the end of the year anyway. If someone decides to be that petty, I'll be petty right back.
If you have extra pop cards at the end of the year, can I?
We won't.
I still have 4 more to get because I gave you that 5 one time. I'm so excited.
Brain.
Oh. I know. Oh my gosh, yeah.
Well, that's what I was.
Yeah.
Yeah, it's not.
That's secant, not. Now you want to group them? There you go. Also, just because you see numbers like 1 and 2 and square root of 2 and square root of 3 doesn't mean they're the special angles. Oh, no, because it's on adjacent, that's going to be positive. Just so you know, this guy's negative. Frank? Frank had like a 3-second delay there. Not in that one. Because cosine's positive. Hey, double check your triangles. Double check my triangles. I had to change that. But it's not, because tangent is negative. Tangent can't be negative if you're in quadrant 1. So the very first thing you should do is determine what's positive and what's negative. That way you know what quadrant you're drawing your triangle in. Okay, 49 minus 25 is 24. Square root of 24 is reduced to 2 root of 6. 3 minus 1 is 2. Square root of 2. But I'm in quadrant 4, so negative. Tangent will be negative, negative over positive. Secant and cosine will be positive because adjacent over hypotenuse, hypotenuse over adjacent. Tangent is opposite over adjacent. Sine is opposite over hypotenuse. Because this is in quadrant 4. Positive x, negative y.
Wait, secant is cosine, but tangent is.
Because cosine is positive. Sine is not negative in quadrant, or sine is negative here. Opposite over hypotenuse, negative over positive. Sine is negative, tangent is negative, cosine isn't. From there, no you. If I do sine, cosine, tangent, cosecant, secant, cotangent, we were given secant is root of 3. That means cosine will be root of 3 over 3. I suppose we should switch colors here. And we were given sine was 5/7. If sine was 5/7, cosecant is 7/5. If secant was square root of 3, cosine is root of 3 over 3. Draw my triangle or XYR shortcuts. Do Pythagorean, find your missing side, and game on. Sine should be negative because square root of 3 or square root of 2 over square root of 3 rationalized is negative square root of 6 over 3. Its reciprocal, root of 3 over negative root of 2, becomes negative root of 6 over 2. Tangent is opposite over adjacent, or negative root of 2. Reciprocal, negative root of 2 over 2. Cosine, adjacent over hypotenuse, 2 root of 6 over 7. Its reciprocal, kind of nasty, I'm going to need a 7 root of 6 all over 12 once it's rationalized. So I'd have 7 over 2 root of 6. Up top, have 7 root of 6. Downstairs, 2 times 6 is 12. Tangent, 5 over is just as nasty. You're going to have 5 over 2 root of 6 and have to rationalize, so 5 root of 6 over 12. Thankfully, cotangent is easier, 2 root of 6 over 5.
Okay, so I don't understand the thought process you do for how you put the negative and something on the triangle. I understand how to get the numbers, but then I know that the tangent and sine have to be negative, so you have to put a negative at the end.
This is x, which is adjacent. This is y, which is opposite. And this point has to be positive, negative. If I'm in quadrant 4, positive x's, negative y's. Positive x's, negative y's.
So then how do you figuring out
Because square root of 3 over 1 is positive over positive. More of these. Y'all really did have a lame student teacher for geometry, didn't you?
Cosecant, okay, go through that cosecant and cotangent first.
Cosecant is hypotenuse over opposite. Square root of 3 over negative root of 2. Rationalize. Getting negative root of 6 over positive 2. What you could do is just find all your trig ratios and then just tack the negatives on the appropriate things. Okay, I think that's kind of what Maddie was saying. Like, just find your normal ratios. Pretend everything is quadrant 1, and then go throw your negatives on the appropriate values. You could do that.
Did sign X and then because you're going down to negative 20, just had negative. Or would that work?
I think so, yes.
Does that make
If I'm picking up what you're putting down, yes. Okay. Normally we kind of rush through those. We need more. Oh, and I don't even have extra practice because we're not used to that. You probably got room over here?
No.
You should.
That's where I put the thing that we did.
This is the same example we're on.
Oh, I got you.
Okay.
Yeah, I have room.
Just make something up. We're gonna say cotangent is 4 negative 4/5. Eesh. Go.
You like figure out before you draw your reference triangle, like which one it would be if you just draw one and like correct it. That seems
Said stage 1 is figure out what quadrant you're in. Yes. Wait. Sorry, I'm upside down.
Like-
No.
What? Oh, so it'd be this one? Wait, I thought.
It's in quadrant 2, but you drew your triangle backwards.
Oh, I'm so smart.
Cosecant is reciprocal of sine.
Oh, it's positive.
So it'd be like, so, I know. I just had a moment.
If cosecant is positive, then so is sine. If cotangent is negative, so is tangent. Tangent is opposite and adjacent.
I'm just confused on how we did this. Like, did we just do like the?
Pythagorean.
Yeah, but for some reason I just do it wrong. Like, can't you do the cheat where it's like the square root of like this squared plus this squared, and that equals it?
Yeah.
Oh, so that's okay. But then that.
You just have to remember whether you're adding or subtracting those values. Depends whether you're finding the hypotenuse or the leg. Okay, so hopefully we're getting the triangle part right. Okay. I will be in quadrant 2, because that's the only place that tangent is negative but sine is positive. Be careful about your signs. Cotangent is what over what? Cotangent is adjacent over opposite. So I start by putting a 4 and a 5 here, and then decide where to put my negative. Which one's negative if I'm in quadrant 2? The 5, because it's the x value. X values are negative in quadrant 2, y values are positive. Yeah? Because remember, negative 4/5 is the same as negative 4 over 5 is the same as 4 over negative 5. It just said negative 4/5. Oh. Sorry, I got Jacobed.
I was like,
What?
how'd you?
Sorry. I got Jacobed.
What?
I got Jacobed. Sorry.
What is it? I feel attacked. You only did it too. Jacob didn't get Jacob.
Do Pythagorean. It ain't pretty. And then you're off to the races. Opposite over hypotenuse, rationalize. Cosine, adjacent over hypotenuse, rationalize. Tangent, reciprocal. Cosecant, flip and rationalize, or just do hypotenuse over opposite. Same thing for secant. Okay. Expect one of these on your next test, for sure. Because this kind of combines like 5 different concepts. Where things are positive and negative, what your trig ratios are, how to find missing sides of a triangle, which quadrants have which properties. It's all smacked together in one thing. Okay? So it's very commonly one of the problems that I'll include. Okay. Ew words. Blah blah blah. Robo arm picks up ball, turns around, drops ball. Specifically, I want you to pay attention to a couple of the bits of wording in here. It says it's going to rotate 225 degrees blah, 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 relative to the point 0. That means I'm always going to put my starting position in initial standard position, positive x-axis. That way I can map it to something I'm used to, okay? So we'll start with, it picks up the ball at positive x-axis. Says the arm is 20 centimeters, it's going to rotate 225 degrees. This is just an application of what we were just doing. If I were to turn that into triangle, what would theta prime, or the reference angle, be? Mm-hmm. 45. So if this is 45 degrees, I know that it has the ratio 1, 1, root of 2. If I'm down in that quadrant, do any of those have to be negative? I'm getting there. And then, those are the ratios between the sides. But they told me that the arm was 20 centimeters. Which means I have to scale this up to find the actual triangle. 20 is in the square root of 2 spot. I need to know what is in the 1 spot. Shoop, shoop. Multiply the two that line up, divide by the one that doesn't. I get 20 over root of 2. Root of 2. Rationalize. Getting 20 root of 2 over 2, which is 10 root of 2. So I now know that instead of negative 1, root of 2, I know this is 20, 10 root of 2, 10 root of 2, both negative because I'm in that quadrant. And if I know that whole opposite adjacent business, if I know my X, Y, R shortcuts, I know that because this is adjacent, because this is opposite, that this is X and this is Y, they're asking, find the position of that ball that gets dropped. They're asking for a coordinate. A coordinate is an X and a Y. Its position is how much lateral and vertical movement. So it's negative 10 root of 2, negative 10 root of 2. That is its coordinate. Yes. And this is a bare bones example of how trig is actually used in engineering. Especially kids coming up into pre-calc, I hear a lot of folks saying stuff like, I'm going to go to mines. I'm going to go to school of mines. I'm going to be an engineer. I'm going to do this. I'm going to do that. There you go. That's the basics of it. Okay? The idea of programming things using math to describe the physical relationships between them. If this remotely interests you, we have a robotics club. Okay? They go to competitions. They're not quite at the stage of being able to do battle bots yet. So. Yeah, we'll pick up with that one tomorrow. So I lied, I guess we build the unit circle tomorrow. Thursday. Today's day 1. Oh. Okay. I like to give it 1 or 2 days after we finish section 4.3, because then you've got a little time to work with.